Emmanuel Schmidbauer to turn on camera. Thank you, Emmanuel, for being again with us and being an active developer for the past few years. Couple of nice contribution coming from you. Last year you presented about this presence publishing between the nodes. Today you come back with another, let's say, module that helps by integrating on distributed systems and for scalability. This new module called NATS, which I found a little bit confusing, given that in SIP voice over IP we have a lot of NATS terminology and we refer to it to network address translation, but apparently someone else choose a similar name for a completely different type of technology, this distributing message bus. Thanks for joining again, knowing it's a little bit early or not yet. It's getting also to you a bit late in the day, like not very early, I mean. And I let you now take the floor and looking forward to your presentation.
Thank you. Thank you, Daniel, for having me. I'm honored to be presenting again. I hadn't planned on presenting. I had a phone call with Fred, and we were talking about something I was working on with the NATS module, and he was like, "You should present on it." And so here I am. I will share my screen and start the presentation. Whoops. So yeah, I wrote a NATS module. NATS is a message queue, a distributed message queue. So I thought, well, I'd like to combine my two favorite software projects, which is Kamailio and NATS. So I'll be talking about the new NATS module on this presentation, but first I'll just introduce myself. My name is Emmanuel Schmidbauer. I'm a software developer at Vector Ventures. We work on some pretty cool projects, mostly in Go. We use Kamailio, FreeSwitch, Kubernetes. I've been a Kamailio developer for a few years now. I've been working with SIP for over a decade, and I'm a Go enthusiast, not the board game. I don't know how to play the board game. So yeah, that's me. I'm going to talk about the NATS project, just give a quick introduction to that. And then I'm going to talk about the module that I wrote. And then I'm going to show how easy it is to spin up a NATS cluster. And then I'm going to talk about what I'm experimenting with NATS and using asynchronous routing, leveraging NATS and microservice architecture. I'm not going to talk about NAT, which, as Daniel mentioned, can be a little confusing because this module has nothing to do with NAT, which is network address translation. So what is NATS? NATS actually stands for Neuro Autonomic Transport System, which is kind of a strange name. I don't know why or how they came up with that. But it's essentially a distributed message queue. It's open source. It's written in Go. I think it was originally written in Ruby, but they rewrote it in Go. So that's pretty cool. Its key features, why I really like it is it automatically manages the addressing and discovery with Gossip protocol. It's super lightweight. As I'll demonstrate, you can run a cluster locally, but you can deploy it almost anywhere, VMs, bare metal, Kubernetes, super easy to deploy. And it's got fault tolerance built in because it's so easy to cluster because it manages all the addressing discovery between the NAT servers. So you can spin up a redundant cluster very easily with little knowledge of the product. NATS uses something called subject-based messaging, which basically means the messages are published with a subject, and that's a way just to scope the messages so subscribers can listen for a subject and get all those messages. And in that way, publishers and subscribers can connect to each other based on the subject. They don't have to really be told to connect to each other. You just have a subscriber saying, I want messages for this subject. And then you have publishers sending messages with that subject. And all of a sudden they're connecting and getting messages. Another concept in NATS I want to talk about is queue groups. Queue groups are a way of um, basically doing load balancing. When you have a group of subscribers, but you don't want all the subscribers to be getting every message, you can load balance by having your subscribers connect using a queue group. And those are not defined in the server, they're defined by the application. So you could easily spin up any number of queue groups as needed with different distribution methods. So it's really ideal for scaling because it's so flexible. Being able to add, remove subscribers in queue groups as needed is pretty powerful. So NATS is a lot more than this, but for the purposes of this presentation, I'm really just going to talk about those two things. I plan on extending the module to basically support a lot more features in the future, but right now it's basically this. I just wanted to go through kind of the pros and cons of NATS as a distributed message queue. The pros are super low CPU, it's super fast, sub-millisecond, it's got high availability and scalability built in, and it's lightweight. So it's really easy in Kubernetes or other Docker orchestration systems. And it's really simple to set up. The cons, it has no data persistence built in. So if you're not connected to, if your subscriber is not connected, they're just not going to get the message. They have to be connected to get the message. There's no transaction, there's no delivery modes, and there's no enterprise queuing. Interesting enough, the NATS project has been working on something called the NATS Jetstream, which basically addresses all of those cons. And so enabling NATS Jetstream will give you those things, but the module does not support Jetstream as it's pretty new. I think it was just released in the C library maybe a month ago or so. The NATS C library, it was a pleasure to work with. They do a lot of the heavy lifting for you, and it comes with two adapters, libevent and libuv. I went with libuv just because looking at the two projects, it looked like it was kind of more maintained and more up to date, although both projects are pretty active. But yeah, there's a ton of documentation around the C library, and it's just really easy to work with. And I wanted to take this opportunity to thank Victor for submitting the NATS C library to the Debian distribution. So hopefully soon that'll be packaged and released with Debian. So it'll make things a lot easier to get the Kamailio module, the NATS C or NATS Kamailio module out to everyone without having to compile. The NATS module configuration is very straightforward. Basically, you can connect to up to 10 NATS URLs. If any of those fail, as long as it stays connected to one, you should be fine. You can pass credentials in the URL as noted here. And then you just define each subject and queue group. The colon here is the delimiter between the two. And each one of those subject queue group definitions spawns an asynchronous process using the libuv. So basically, each one is a worker, and you can run as many workers as you need. Although one worker per subscriber is probably enough. I haven't run into a case where you needed more than that, but it does give you the ability to scale, and I'll talk about that later. Besides that, you just need an event route with the subject name, and you get the message payload in that event route. So every message that comes into Kamailio, into the subscriber, will execute the event route with the NATS data payload. So it's pretty simple. I'm going to talk about a couple different ways to configure using these parameters. Basically here, I'm doing I'm basically load balancing to multiple workers within Kamailio. So each one of those subject queue groups spawns a worker. And because they have the same queue group name, the messages get load balanced to each one of the workers. So if you did feel that you needed to scale out, you could just add multiple workers with that parameter, and the message will get load balanced to each one of those workers within a single Kamailio instance. This is an example of load balancing messages between multiple Kamailio instances. So in the diagram, I've got 3 instances. They're all using the same queue group name, which is worker 1. So when a message is published on the Kamailio World 2021 subject, those messages are automatically load balanced between each one of those instances. In this example, which is probably more practical for the purposes of Kamailio, you would want Kamailio maybe to get each Kamailio instance to get a copy of the message. Well, in that case, you just define individual queue groups within each Kamailio instance. So each queue group for the subject Kamailio world will get a copy of the message. So I wanted to show here how easy it is to spin up a NATS cluster on your local machine. Essentially, you're just running the NATS server on binding to a couple ports, and this would be server 1, and then server 2 here is binding to different ports on the same interface. The important parameter here, which connects the 2 NATS servers, is the routes parameter. It's basically saying talk to this NAT server, and giving them the same cluster name is important as well. And once the NAT server 2 is connected to NAT server 1, they both are aware of each other, and you basically have a redundant cluster. Here I'm just demonstrating how easy it is to set up Kamailio to that cluster we just set up on your local machine. Configure the NATS module to connect to both those NAT servers running locally. You set up your event route, and I'm running Kamailio in the foreground here, and you can see after I start Kamailio, I publish a message with the subject, and it appears in the Kamailio log, the payload there. So it's very easy to get going with this, and that's one of the main reasons I really like NATS is it's very simple. So this is kind of what I was talking with Fred about when he asked me to present. I was experimenting with a design where we could basically route calls asynchronously, sending requests into a microservice in Kubernetes, and then publishing a route to our Kamailio cluster, which would basically route the invites. So I'm using a few different modules for this. table just to store the transaction. The TMX module can actually suspend transactions and resume them, which is pretty cool. And then since the NATS module does not have a publish feature yet, I'm just using the HTTP async client to send the route request into the route service, the route API. And then the SIP router API will generate a route payload. It'll publish it to the NATS cluster, and then Kamailio will receive that route payload, and using a transaction ID key, it will find the suspended invite and resume it, and set the destination URI to wherever the invite should be sent. So in this setup, as I mentioned, we're using htable, and that's really just going to store the transaction ID, which if you can see below in the route, suspend route, I'm using MD5 on the call ID just to get kind of a sane value, a unique key. And I'm storing that key in the SIP TMX htable with the transaction index and label, which you get after you run the tsuspend function. So after the transaction is suspended, you store an htable, and then you make your request. And here I'm just sending a bunch of parameters to the SIP router API, which is in Kubernetes, the call ID, the key, which is the hashed call ID, and the to user, from user. And that's it as far as suspending the transaction and sending a request. So now that request goes into your SIP router API, and it does kind of all the logic required to figure out where the call should be routed. In the event route for the NATS module, I'm using the JSON module to basically parse the NATS data payload. And the payload is very simple. It's just the key which was sent in the original request, and then it's the destination URI of where the call should go. And I'm basically looking in, oops, let me go back. I'm looking in the htable for using that key. If the key exists, we know the transaction exists and it's waiting to be resumed. So we parse the transaction data here, and then we continue resume the transaction here, setting the destination URI. Here's kind of a snippet of the Go application, which would run in Kubernetes. It simply connects to NATS, and it is getting requests and forwarding them to the SIP 1234, which is an example, obviously. And then it's publishing them on the SIP TMX subject. I'm not showing the HTTP server here. It would just be boilerplate stuff. Anybody who writes a Go service could probably easily spin up a HTTP server within it and accept the requests. And this is really just showing an example of how you can publish from Go into NATS and then down into Kamailio to route the call. Other uses for NATS, presence. I presented on NSQ last year and how it can be used with presence. NATS could be a drop-in replacement for NSQ in that way. You could also publish SIP authentication credentials if you've got your SIP user data in some external service for management there. anytime that updates, you could publish the payload to Kamailio, which could store it in HTable and perform SIP authentication there. You could publish static route updates if you want certain calls, like from certain users. You could publish that into Kamailio and use, again, use HTable to store that in memory. Another idea is just to, much like the permissions module, you could just publish IP address lists into Kamailio and store that and check the source IP address against them. So there's a ton of uses for it. Just depends how much you want to put in NATS, I guess. And I plan on doing a lot more with this module. As you can see, it's kind of limited. It's just using queue groups and subscribing to them. I've kind of omitted a lot of the NATS connection options. I've left those as the standard defaults in the module, but I do want to expose those controls to the user. I also do want to add Jetstream support for data persistence because I think that would be a very powerful addition. And eventually you add a NATS publisher so we can send data out of Kamailio into a NATS cluster for other resources. That's pretty much here's my contact info. Feel free to reach out to me. I'm pretty open to having conversations around any of this stuff because I really enjoy it. So that's it.
Thanks,
Thank you.
Emmanuel. Thanks again for this presentation and the contribution to Kamailio. Yeah, that was one of my questions, but you touched it with the last part, like difference with the NSQ, knowing that you developed that module as well for Kamailio. From the YouTube, I see a question from Stefan Mitelu. I think you also touched a bit, but to clarify it, can NATS module currently act both as a publisher and as a subscriber, or just as a subscriber? I think the last one had the answer. The last slide.
Yeah, right now it's just a subscriber, but I absolutely plan on adding the publisher to the module. Just a matter of when.
Okay. Earlier was one from Hans Jürgen. Can I compare NATS with RabbitMQ and QTT in a way or another? Or
Yeah, it's very similar in that it's a message queue. I prefer NATS for various reasons. One of them is the operational overhead of running RabbitMQ is a little bit more in depth and complicated. So the other thing is there's no broker in NATS. I think RabbitMQ and MQTT both require a broker, and that design kind of hinders scalability because it kind of creates a single point of failure. So fundamentally, they're very similar in that they're message queues, but there's some differences between the two, which is the reason why I prefer NATS to those.
I have also a question, another question. Thinking because you mentioned it's more like key value storage or distribution of key values. Does it support other data types like sets or arrays, or is simple key value always?
Yeah, so you can send any payload you want. I've just typically stuck with JSON because it arrives as a string. But yeah, it's really up to the user on what payload to send.
Okay. So internally, because like if I think from the Redis perspective, it's mainly a key value, but then you have like a hash map or a couple of other data structures that you could push to Redis. Anyhow, this looks interesting, and especially this simplicity to deploy and work with. It's really a key factor from my perspective whenever I look at these distributed systems. Otherwise, adding complexity where distribution is anyhow something complex makes it even harder to deal with. So that would be Emmanuel. Thanks again, and see you around our community. Looking forward to your new contribution for next year edition, right? So,
Daniel, would you allow another question?
Yeah, one more question from Wolfgang.
It's quite similar to your question. I was just wondering if there is a kind of restriction in the payload size, or can you actually put anything into the payload?
Yeah, so the documentation for NATS says less than a megabyte. So I mean, it's pretty big, but yeah, I wouldn't send huge payloads because I've also read that larger payloads are slower, which makes sense. But yeah, as far as the size of the payload, it's probably pretty large. So
I was just considering if I can put the whole SIP message into the payload, into a JSON, whatever, and send it over, and being it processed somewhere else and get a result back.
If it's not WebRTC with a lot of joking.
Okay. Yeah, thanks for the answer. Thanks.
Okay, Emmanuel, see you around the community. Thanks again.